Before we go too far, we need to understand how the engine will respond to ignition timing at idle and what sort of numbers it may want to see. The effective ignition timing at idle is no different than it is under load. As we advance the ignition towards MBT timing, the engine will produce more torque, and this will tend to make the idle speed increase. If we retard the timing, conversely the idle speed will drop due to the reduction in torque. The first point here is to make sure that the ignition timing numbers in your idle area are smooth and consistent. Erratic changes in the timing numbers will make it hard to hold a stable idle. Secondly, we need to choose the idle ignition timing, and there's no set in stone rule for what this must be. After tuning thousands of different engines, I find that most will idle nicely with ignition advance in the 15 to 20 degree vicinity, so this is where I would suggest starting out. 15 degrees is almost certainly going to be less than the MBT timing, but there are some advantages in doing this. Many ECUs now give you the option of using an overlay table to alter the ignition timing in relation to the error between actual idle speed and target idle speed. This works on the principle that advancing the timing towards MBT increases idle speed, while retarding will reduce it. For this to be effective though, we need to have the base ignition advance set below MBT, so there is some scope to move the timing both ways. You can see how the engine responds to timing at idle by increasing it a couple of degrees at a time. You will notice the idle speed increases slightly. When you get to the point that there is no increase, this is going to be pretty close to MBT. If you want to make use of ignition idle control, I recommend retarding the base idle ignition by 6 to 8 degrees from this point. If you have an engine that is heavily modified, and particularly one with a large cam that provides a lot of overlap, you'll usually see more stable idle speed control with a slightly more retarded ignition timing. I find that 12 to 15 degrees usually works well, but you'll need to adjust the timing and see how the engine responds. The slightly retarded idle ignition timing reduces torque and makes the idle lope of a large cam less pronounced.